Hello, so what we're going to do today in this video is we're going to differentiate the function R Cosh of x with respect to x. So R Cosh is just the inverse hyperbolic cos function. So just like arc cos of x is the inverse, so this like inverse cos function. So R Cosh of x is the inverse cosh function essentially. I mean, we could use this notation with this this notation on the right hand side with these minus ones in the like quote unquote power, but I prefer to use this notation. I think I mentioned this in a previous video, just because this is not a power of -1. This just is just notation to denote an inverse function in the case of trig functions. So I prefer to use this arc or R notation instead of this on the right hand side over there. But anyway, yeah, so let's get on with differentiating this function. So the inverse hyperbolic cos function. So a similar process to my previous video when we differentiated the R sinh function, the inverse hyperbolic sine function. What we're going to do is we're going to let y equal R cosh of x. And so if we apply cosh to both sides, that apply the cosh function to both sides, what we're going to get is cosh y equals, so cosh of R cosh, obviously that cancels out because they're inverse functions, so you just get x there. And then the next step that we've done in previous videos, and we're going to do again in this one, so apply d by dx to both sides, so differentiate both sides with respect to x. So the left side is going to give us d by dx of the cosh of y, and that's going to equal d by dx of x, which is obviously just going to be the number 1 because differentiating x with respect to x, well, that's just 1. So that's 1 there. Okay, so then we need to sort out this left-hand side. So again, like previous videos that I've done, it's just going to be implicit differentiation, which is just another way of saying the chain rule in this case. So we want to differentiate this cosh of y, which itself is a function of x. So that's why we can do this implicit differentiation stroke chain rule. So yeah, what we're going to do is differentiate the inside of that cosh function. So that's just going to give us dy by dx, and then differentiate this cosh of y with respect to y. So that's going to be sinh of y. It's a hyperbolic sine of y, because when you differentiate cos, you get sinh. So brilliant. Yep. So what we now know then is the left-hand side here equals dy by dx times sinh y. Okay, great. So let's write that on the next page then. So therefore, dy by dx times sinh y equals the number 1, and we can divide both sides by sinh y to get dy by dx equals 1 over sinh of y. Okay, great. And yeah, so we know that y is literally equal to R cosh, and that's what we want to differentiate, R cosh. So we know then, therefore, that d by dx of R cosh of x equals 1 over sinh y. However, of course, you've got this y variable on the right-hand side, which we need to eliminate. So again, the key with this is that we're going to need a trig identity. So similarly with when we differentiated R sinh, we'll need this trig identity, or this hyperbolic trig identity, cosh squared y subtract sinh squared y equals the number 1. So rearrange to make sinh the subject of the formula. You should get that sinh y equals the square root of cosh squared y subtract 1. So we're just going to plug that in up here. So this equals 1 over cosh. So cosh y all squared. Subtract 1. And of course, we know from a previous slide that cosh of y equals x itself. So we can just plug in x. So 1 over the square root of x squared subtract 1. And so therefore, in conclusion, when you differentiate the inverse hyperbolic cos function, so R cosh of x with respect to x, you're going to get 1 over the square root of x squared minus 1. And that's our final answer.